This is Bloomberg Businessweek Daily, reporting from the magazine that helps global leaders stay ahead.
Well, you know this if you've been watching or listening to us over the last 90 minutes. President Trump Friday signing orders meant to accelerate the construction of nuclear power plants, including small, untested designs that offer the promise of rapid deployment, but have yet to be built in the U.S. It certainly makes sense, given the increase in demand we are set to see for energy. The question that a lot of people have, though, is what are we going to do with all that nuclear waste? Well, Deep Isolation says we bury it deep underground, and they're working on it. We got Rod Baltzer with us, CEO of Deep Isolation. He joins us from Plano, Texas. Also with us here in the Bloomberg Interactive Brokers studio is Bloomberg News energy reporter Will Wade. Will, I want to start with you because when you think about waste, what are the things we need to be thinking about?
We need to think about something that is long-term, like really long-term. This stuff is dangerous for centuries, for longer than any of us will be around. So you need to look for a permanent solution. And that's something that we've all been working a lot. Really, Finland is the only country I know of that's got something they've worked on, a deep underground repository for the waste. Everywhere else in the US, it pretty much just sits out behind the reactors where they used it.
Yeah. Happy Friday, everybody, if you weren't freaked out. Hey, Rod,
don't go to the reactors. I mean, it's pretty simple.
I mean, it's not like it's radioactive. They're in these like gigantic concrete canisters. I've been there, but
as long as there's no crack or anything, right?
They're designed to last for a really long time, but they just sit out there and take up space. There's some power plants where they built the power plant, used the power plant, finished the power plant, took it apart, cleaned it up. The only thing left
is a
couple dozen or more of these giant concrete storage canisters just sit there.
All right, that's what Deep Isolation is working on. Rod, come on in on the conversation. Tell us a little bit about what you guys are doing specifically when it comes to nuclear waste, because we know kind of, as Will so well spelled out, what's being done now. How are you guys approaching it, and what can you do differently?
Yeah, thanks for having me on. So deep isolation is different. What the world has typically done, like Will said, in Finland, giant mine repositories. They take decades. They're very expensive. Administrations change. They get bogged down in politics, and they're just really hard to implement and really costly. And so deep isolation looked around and said, man, directional drilling has really come a long way in the last 20 years. What if we married that with nuclear waste handling that we've been doing for decades as well? Make sure we don't drop anything, make sure we integrate those two really mature technologies, and then we can go deeper, which is safer and extends for those really long periods of time. And
directional drilling, you mean this is basically the same technology we use for fracking, right?
It's the same kind of technology, but we don't frack. So we want that formation to be pristine. We don't want to break that rock open like you do with fracking.
So you still have to find somebody's backyard to put it in. And even if it's deep underground, I get the sense that states, cities, countries still won't want it. Where do you put it?
Yeah, and so that's where it's kind of fascinating. For a mine repository, it had to be centralized, and you pretty much had to take all of the waste from the entire nation. So we were going to put it at Yucca Mountain, Nevada, and Nevada did not want it. But now it's stuck at all these reactors across the U.S. So there's communities that already have it in their backyard. The question is, do you want to keep it up there and just look at it, or do you want to put it safe underground where it would be better disposed of? What we're also seeing is internationally, there's a lot of interest from smaller countries that don't have a lot of nuclear of co-locating this with the reactors, so you don't have to transport it through nuclear neighborhoods or communities.
I still didn't hear, though, where exactly you put it. I know that it's not, Yucca Mountain is not worked out for the last, almost 40 years at this point. It's pretty remarkable that it goes back that far. But where in the U.S. can you put it?
But right now, you can't put it anywhere except Yucca Mountain. There's the Nuclear Waste Policy Act says thou shalt only dispose of spent fuel at Yucca Mountain, Nevada. So in the U.S., we're stuck. And so I think, as you see, like these executive orders come out, it'd be great to see some of those with nuclear for the waste side and make some progress on it to allow us to look for another site. We can't even look for one yet.
Listen, years ago, 25, 30 years, I'm dating myself, but doing a whole thing about Yucca Mountain, and because people were upset and trying to figure out what do we do with all the waste that's already there. And here we are, how many years later. Will, why is, from your reporting, and then I want to bring Rod back, underground, deep underground, why is that a good solution?
Well, it's pretty safe down there.
Is it?
Yeah, I would
So
think
even like earthquakes, tremors, like none of that stuff is felt there?
You know what? That's actually a better question for Rod. And my question for Rod is, give us a sense, like, how deep are we talking here?
So we're talking about a mile deep. This is about twice as deep as a mine repository. And so Deep Isolation has done a lot of safety calculations and looked at, when you put the waste that deep and, in a generic kind of formation, a shale formation, how long does it take for that to migrate somewhere? Eventually that canister corrodes and that waste goes somewhere. And our calculations show that the peak dose to somebody on the surface would be 1.6 million years into the future and be 1,000 times less than a regulatory limit of 10 millirem. 10 millirem is about a chest X-ray, so 1,000 times less than that is very, very minimal. And it just shows you that much depth, that much rock provides so much safety and a buffer for such a long period of time.
So when we have it in the storage canisters on the surface, the safety comes from the couple of feet of concrete and steel that are protecting it. It sounds like your safety play is we're going to put it so far away that it's not going to bother anyone?
Yeah, ours is the billion tons of rock that's on top of our formation instead of the feet of concrete. And nuclear waste is stored safely. It doesn't smell, thank goodness, so people would really be upset about it being just hanging up there. But it's stored safely. And so, ours is we can make it permanent. Let's stop spending $2.2 billion a year in the U.S. on storage and do something on the disposal aspect.
Here in New York City, when it gets to the environmental review process, if they want to turn some sort of area that perhaps used to be a factory or a gas station into apartments, there's this remediation process that has to take place because some of what was there over the last 100 or so years has seeped into the ground and it's become an issue. It's certainly an issue in a large part of Brooklyn right now, for example. How do you ensure that 100 years from now, your solution will still hold? Because really it's untested over that length of time and the nuclear waste will not have seeped into the area around it or contaminated the groundwater, for example.
Yeah, we have nuclear facilities that have been open for more than 70 years, storage for more than 60 years. And so we've got some experience with, how do you create the engineering barriers around that? Ours is trying to take that plus the drilling technology and just move it all super deep underground so that it is, nowhere near the surface. So when you're doing that surface testing, this is a mile deeper than that. It's well below any kind of drinking water aquifers or anything else. Just get it out of the biosphere.
So tell us how much work you guys are already doing. And because if it's so good, like are people queuing up to say, listen, we're going to need you to do this for us? So give us an idea of the business that you're seeing.
Yeah, so what we've done is we've designed a universal canister system. And so this canister will take a spent fuel assembly, whether it's a legacy reactor or some of the new advanced reactors and the new fuel types, and it'll enclose that waste. And that allows us to put it either in a storage or transport container for a surface if we need to move that around or store it temporarily, or dispose of it in a mine repository or a borehole deep underground. And so we've actually produced those both in the U.S. and the U.K., and we've tested those near surface to make sure that they work. They fit inside the drilling casings. They get handled with oil and gas equipment. We've done corrosion testing and things on these, and so we know they're robust and ready to go. Our customers have told us we need to do a full-size, full-scale at-depth demonstration. We've done a small-scale at-depth and full-size at the surface, but go deep. And so that's our next step is finding the funding to go do that next step and make progress on this issue.
What's the main barrier you see to actually getting this used? Is it still developing the technology? Is it finding a customer willing to try it? Or I suspect one of the biggest one is getting regulatory approval to let anyone use it.
Yeah, we've got a lot of interest from customers. We see the technology as being pretty mature. We do think it's the first mover and the regulatory aspect alongside that. So, like we said, in the U.S., there's some complications. We do think our technology is probably exported and done internationally first, but we do see that there's openings for that, and that there can be progress made in the next 3 or 4 years.
What does it cost to do this? How expensive is it?
So this is less than half the cost of a mined repository. So it's, general rule of thumb is probably about $1 billion per reactor for spent nuclear fuel disposal as you look at kind of reactor sites, and we're less than half that cost. And so when you're a small country or you're looking at new nuclear or anything and you want to have an economic solution, this is one that you could afford to implement.
One last question I'm also curious, Rod, is how do you keep it safe? Like what's the procedure for checking on it, making sure that once it's built, it continues to be safe? And if there's a problem, is it easy to fix it?
Yeah, so we do build retrievability into our product. So if you found out after the fact that for whatever reason you missed something and it wasn't safe, you could retrieve it and pull it back to the surface. So it is retrievable, it's reversible. Likewise, if new technology came along and you really wanted to reprocess this, you could do that as well. But for us, we also have a lot of monitoring. We've got a lot of patents and IP around monitoring, both during operations and post-closure. So what is that temperature, pressure, the radiation like at depth over a long period of time?
Cool stuff. Thank you so much. Rod Baltzer, he's CEO of Deep Isolation, and our thanks to Will Wade, also weighing in there, Bloomberg News energy reporter. Thanks to you both.